If you want to give your game a sci-fi feel, a great way to do that is to add holograms. These light-based imitations give any scene a futuristic feel, and today we're going to use Shader Graph to turn any mesh into a hologram. As always, there's a GitHub project in the description. Holograms have two main parts. First, a bright edge. For this, we can take advantage of Fresnel lighting, which illuminates parts of an object viewed at a very shallow angle. This means curved edges will show up very brightly. Second, we'll draw some holographic scanlines moving down the object, to make it look like it's being constantly drawn and redrawn. I've opened a brand new project with the URP preset so that the scene is appropriately set up. I'll start off by creating a new graph by right-clicking and going to Create, Shader, PBR Graph. Let's set the Fresnel first. Unity has a built-in Fresnel effect node. Add one to your graph and set the power to around 4 or 5 so the edges are a bit thinner. Then add a new color property called Fresnel Color. Set its mode to HDR so that we can artificially boost the luminance of the Fresnel. I've set the default color to white with intensity 2, but we can tweak it later to whatever we want. Multiply the Fresnel effect together with the Fresnel color. That's all that needs to be done for the Fresnel calculation. Now we'll add another color property called main color, make it HDR, and also make it white by default, but give it a lower intensity than the Fresnel color. Plug this into the albedo channel on the PBR master node. While we're here, also set the alpha clip threshold to 0 and use the cog drop-down menu to change the surface to transparent. Now we'll handle the scanlines. We could generate these programmatically, but instead, I'll be using a texture I made beforehand which encodes the strength and position of the scanlines. The darker the line is, the less visible it'll be. You can choose to use a higher resolution texture if you want. First, add a texture 2D property called hologram scanlines, and assign the texture we just mentioned as the default. We'll start by using a sample texture 2D node to sample the texture, but we won't be using the object's UVs to sample. We want the scanlines to move downwards across the object along the global y-axis over time, so we'll actually start with a position node with the space set to world. To get the y component, use a split node and take the g output, RGBA corresponds to XYZW, and then connect that to an add node, because we're going to add the time component to it. We'll add another property, this time a vector 1 called scroll speed, with a default of 0.05. We want to multiply this together with the regular time output of a time node, which just counts upwards at a rate of 1 second per second. Then plug that into the other input to the add node we created earlier. Next, we need to create a vector 2 and connect the result of the add to the y input. The x component value doesn't matter since the texture wraps around in the x direction anyway. We're almost there. The only thing remaining is to make sure the scanline texture tiles appropriately. We'll do this with a final vector 2 property called hologram tiling. The default value will depend on the resolution of the scanline texture, but I've set mine to 64x64 since the texture is 32x32. The vector 2 we created earlier needs to be output into a tiling and offset node in its UV slot. Then we can drag hologram tiling into the tiling pin. Once that's done, connect the output of that tiling and offset node into the UV channel of the sample texture node. All that needs to be done now is to connect together the two halves of the shader. Add together the result of the multiply node from the Fresnel and the sample texture node from the scanlines, then use that as the input to both the emission and alpha nodes of PBR master. With that, the shader is complete. If we create a few materials and attach them to some objects in the scene, you'll see the hologram effect in action. As you can see, the effect looks best on objects with curved surfaces because of the way the Fresnel works. It doesn't work quite as well on flat surfaces. As always, thanks to all my patrons who make these videos possible. If you'd like to support me, consider subscribing or maybe even throwing me a few quid on Ko-fi if Patreon isn't your thing. Also, let me know in the comments if there's an effect you'd like me to tackle. I'm always open to ideas. Thanks for watching, see you next time.